Hey everyone, in this chapter we're going to be talking about the simplest short-run macro model. So we're going to be talking about the macro model, but we'll start off by simplifying it, and then in the coming chapters we'll expand it again to include some of the other components. But before we do any of that, let's talk about something called desired aggregate expenditure. And you have a formula right in front of you. Now, if this formula looks familiar, it's because it's the same formula as GDP. Really, the difference was that in the GDP we had those little A's, which and the A stood for actual. But the main thing you have to understand here is that although they have the same formula, they are not the same thing. Think of GDP, or national output, as production. What is the total value of goods and services produced in a country? Okay, production. Aggregate expenditure is the total value of goods and services purchased within a country. What is our desired expenditure? What are we actually spending on? And we're going to talk about an equilibrium at some point, but let's start off there. Okay, lock that in. GDP is production. Aggregate expenditure is purchases. Now we have two broad categories of expenditures. We have autonomous expenditure and we have induced expenditure. Think of these as fixed and variable. Autonomous expenditures are expenditures that you're going to spend regardless of your income. So in an economy, there's always going to be expenditures that are spent regardless. There's always going to be a little bit of consumption, even if you have no income. Like, you still have to live somewhere, you still have to eat. So even without income, there's still some money that you're going to be spending. Induced expenditures are expenditures that are tied to your income, that increase as your income increases and decrease as your income decreases. Why I called those variable before. So think of autonomous as fixed. If you're thinking of this in like a linear fashion, autonomous is fixed. It'll stay the same regardless of your income, and it'll be there even if your income is zero. Induced is variable. If you were to draw this as a line, and we'll see that, it would be the slope. Okay. So let's talk about consumption to start. This is one of the big ones. We talked in the previous chapter that consumption, this is any expenditures on goods and services by end users. When I go out and I buy a pair of shoes, or I go to the restaurant and I have a meal, or I pay for my electricity, I am the end user of those goods and services, and so that would be part of consumption expenditure. So what are the key things to know? First of all, something called disposable income. Disposable income is basically all the money that we have available to us after deducting our taxes. So I make $100,000 this year, I have to pay $30,000 in taxes. The other $70,000 is my disposable income. My consumption is based on that. It's based on, I have $70,000, and there's two things that I can do with my disposable income. I can consume it, or I can spend it on consumption, and I can save it. And that's what we're talking about here. Your disposable income goes to two places: your consumption and your savings. Any income that is not consumed is assumed to be saved. So there's something called the consumption function, which I think I should have somewhere here. Right there. So let's zoom in on this a little bit. So total consumption expenditure is made up of two things. This is your autonomous consumption right here. Again, that's your fixed consumption. You are going to consume that, or we as an economy will consume that regardless, even if our income is zero. And then you have this part here, which is the induced. And you see, this is a function of your income. It depends on your income. MPC, think of that as your slope, marginal propensity to consume. You have all the definitions here, by the way. But the marginal propensity to consume is basically the fraction of every dollar of income that you're going to actually consume. So say, for instance, you had an MPC of 0.5. It means every dollar of disposable income that you earn, half of that will be spent on consumption. The other half will be saved. Which leads me to, we're going to be bouncing back and forth between things. So You also have a savings function. Your MPS, which is your marginal propensity to save, is just 1 minus your MPC. So remember the example I gave? If my MPC, and I'll change the number so it's less confusing. If my MPC is 0.6, my MPS will be 0.4. The logic being, 0.6 means every dollar I make, I will take 60% of it and consume it, spend it on consumption. I will then save the other 40%. You have a few small formulas here, probably less important, but still you should know them. MPC, how do you actually calculate the marginal propensity to consume? It's just a slope. It's the change in consumption over the change in income. And then APC, which stands for the average propensity to consume. This is the percentage of every dollar that you earned that is spent on consumption. And it's a little bit different from the MPC. MPC is a slope, meaning it tells you for the next dollar. How much of the next dollar that you earn will you spend on consumption? So it doesn't factor in things like autonomous consumption, whereas the APC does. APC takes your total consumption, which now we understand is a sum of two things, autonomous and induced, and measures, okay, out of all of my disposable income, how much did I spend on consumption? So you have this graph. I'm going to try and explain it to you before we get into some practice questions. This is your consumption graph. You've got the 45-degree line that starts at the origin. That just represents your income, your real disposable income. And then this line that starts off over here, that's your consumption. The intercept of that is your autonomous consumption. Remember what I said? Even if your disposable income were zero, you still have to spend some money. You still have to eat. You still have to live somewhere. And so even with zero income, you're spending some money. And then as your income starts to rise, your consumption starts to rise because you have your induced consumption that's starting to kick in, which is this portion here. Now, what's with the green and blue red areas? Over here, you've got an equilibrium where the two are exactly equal. Think about what that means. If your income and your consumption were equal, it means you are spending all of your income on consumption. Think about that. All of your income is spent on consumption. If you made $50,000 this year, you took all of that and you spent it on immediate consumption. Now, on the right, think about what this means. Your income is higher than your consumption. You earned more money than you spent. That means you have positive savings, and that's the green. You have positive savings. That's what I wrote at the bottom. You're saving money because you're not consuming all of your income. And then over here on the left, where it's red, you have negative savings because you're actually consuming more than you made. Now, this could be like literally spending your savings. It could mean using debt. We're not really getting into that. The point is that you have negative savings. You're running a deficit, essentially. Let's do a few practice questions on this. Question number 1, consider the consumption function in our macro model. The key factors that influence desired consumption are assumed to be what? So we haven't really spoken about this. I think it's because it's coming on one of the next pages. So these are the factors that affect consumption and investment, but we're talking about consumption here. Interest rates, household income, optimism about the future. And you see here the effects on consumption. When interest rates are high or when they increase, your consumption tends to decrease for a few reasons. It becomes more beneficial for you to save money, so you see your savings will go up. And if you're saving more, you're consuming less. Your wealth. As you have more wealth, you consume more. You also save more. It just means you have more money, so you can do more of everything. And when you're optimistic about the future, you tend to spend more money and save less. But when you're worried about the future, when you think, oh, a recession is coming or the economy is slowing down, you'll start to do the opposite. When you have a negative feeling toward the future, you tend to consume less today and start saving more. So for question number 1, Consider the consumption function in our macro model. The key factors that influence desired consumptions: expectations about the future, wealth, interest rates, and your disposable income, of course, are all factors that affect your desire to consume. Number 2. In a simple macro model, an increase in household wealth is generally assumed to what? We just talked about this. An increase in household wealth means we have more money to spend, so we consume more and we save more. So cause no change in desired consumption? No. Cause no change? No. Cause a downward shift? Cause an upward shift? Or affect only desired savings? So let's look at this consumption function. If we had an increase in household wealth, so an increase in household wealth would cause an increase in consumption, not a decrease. And an increase would be an upward shift of our consumption function. If I have more wealth, every part of my consumption will go up. I'll likely have more autonomous consumption. So when we said that those 3 factors, so the interest rates, wealth, and optimism about the future, when those are favorable, meaning an increase in wealth, a decrease in interest rates, and an increase in optimism for the future, the consumption function will shift upwards. So this entire line will actually shift up. We're going to increase our consumption. So cause an upward shift. And the same is true in reverse, by the way. If we have a negative outlook, so a negative outlook in the economy, so let's say lower optimism, higher interest rates, or lower wealth, that will cause a shift down in the consumption function. Now, notice that I didn't talk about disposable income here, and you want to be careful. This is like in any economics. Whenever you have an endogenous variable, meaning a variable that is actually explained by the model, that would not cause a shift. So if I said, for example, that you had an increase in your disposable income, not your wealth, but your disposable income, that would not shift up or down. That would just move you to a different point. Let's say your disposable income went from 1 to 2, well, then you would just move to a different point along the same line. But these are exogenous variables. These are external factors. External factors cause actual shifts in the line. Number 3, consider a consumption function that is upward sloping but flatter than the 45-degree line. Okay, that's standard. When real disposable income rises, this is what I just talked about, desired consumption will fall and savings will rise. Okay, so when disposable income rises, so think of this graph. Okay, I'm just going to clean it up. When your disposable income rises, we move, let's say, from point A to point B. So we are consuming more. Which one says that? Desired consumption will fall? No. Desired consumption will rise? Yes. Desired consumption and savings will both rise. Desired consumption remains constant. So what will happen here? The answer is that they will both rise. Because if your disposable income goes up, you're not spending all of that on consumption. Some of it will be spent on consumption. Some of it will be spent on savings. Some of it will be saved. And if you remember your savings function, this is also a function of your disposable income. So if YD, disposable income, rises, both of these have positive slopes, meaning both your, this is a typo here, I should say S, both your savings and your consumption will increase. Number 4, suppose disposable income for an entire economy rises from 400 to 440 billion and desired savings rise from 50 to 60. We can conclude that the marginal propensity to save, the MPS, so marginal propensity to save, you look at the change in savings over the change in disposable income. So in this case, the change in savings, 10 billion. The change in income, 40 billion. So 25% is my marginal propensity to save. I'm going to save 25 cents of every dollar. What is the definition of marginal propensity to consume? Let's go through the options. The change in desired consumption divided by the change in savings. The change in desired consumption, that's true. Divided by the total disposable income? No. Remember, it's the change in consumption divided by the change in income. The change in consumption divided by the change in disposable income that brought it about. That's the one. Number 6. If the Jones family's disposable income increases from $1,200 to $500, so you have a change here in disposable income of $500, and desired savings increased from negative $100 to positive $100, so your change in savings $200, it actually increased by $200. What are we looking for here? The marginal propensity to consume is 0.4. Okay, so there's a couple things we could do here. If we're trying to find the marginal propensities, let's say to consume, it would be the change in disposable income divided by the change in consumption. Or we could do 1 minus the marginal propensity to save, since they're talking about saving. So let's try that. The marginal propensity to save, like we saw a few questions back, would be the change in savings, so 200, over the change in income, so 0.4. We are saving 40 cents of every dollar. So then the marginal propensity to consume would be 1 minus that. So let's see if that's one of our options. It is. Now, more on that. If you were looking for the average, for the average propensity, I'm just going to move this out of the way for now, and I'll change color. If you were looking for average propensity to consume, you would, and since we're talking about savings here, where you would do 1 minus the average propensity to save, and average propensity to save, you would look at your total savings over your total income. It would be different. Your total savings here would be 100. Your total income is 1,700. So you're really saving just 5.8% of every dollar. So your APC would be 1 minus that. It would be close to 95%. It means you're basically consuming 95%. So the important thing here is that you remember that if you're looking for marginals, you look at the change in income, change in consumption, change in savings. But if you're looking for the average propensity, you look at the totals. Number 7, total desired savings. So S divided by total income is what we just talked about. This is the average propensity to save. So B. Number 8. When desired consumption exceeds disposable income. Remember we talked about this, right? So you've got your income here, that's Y, and your consumption like this. When your consumption is higher, that would be this portion, desired savings is negative. Oh, that's here. So, excuse me. So when desired consumption exceeds disposable income, your savings are negative. And when desired consumption is less, that would be this part here, your savings are positive. Okay, now investment expenditure. We spoke about this a little bit in the previous chapter. So just a reminder, it's made up of 3 things. New plant and equipment. So this could be, new machinery, new factories, that sort of thing. Residential construction is new homes, the construction of new homes. And inventory accumulation. I want to just double click on that for a second. Remember, inventory accumulation is not the same thing as just the production of inventory, because some inventory that is produced is consumed right away. Inventory accumulation is anytime that firms, companies, are producing more inventory than inventory that is being sold. So the inventory is accumulating, but it could also be negative. You can have inventory decumulation or depletion, where the amount of inventory that is manufactured is actually less than the amount of inventory that is purchased. Okay, so it's really a change in inventory and not a production of inventory. Inventory is always assumed to be autonomous, so there's no induced portion. All investment expenditure is autonomous. It's all fixed, basically. Now, the factors that affect investment expenditure, you have 2. Interest rates, same effect as consumption. As interest rates go up, we tend to invest less. We tend to spend less on new plant and equipment. We tend to spend less on manufacturing new homes. And business confidence. As business confidence goes up, then we tend to increase the amount that we're spending on investments. Now we're going to start tying it to aggregate expenditure and GDP. And this is something you're going to do almost in almost every single chapter of this course. Is you'll be learning something, and then ultimately you're trying to figure out how does that affect the economy? How does that affect the GDP? So how do these things affect the GDP? Well, remember that aggregate expenditure is basically the sum of these things. So if any one of these increases, the aggregate expenditure, which is also the GDP, will increase. So if consumption increases, aggregate expenditure increases. GDP increases. If investments increase, same thing. So you could say that an increase in interest rates decreases aggregate expenditure and GDP, and vice versa. An increase in household wealth, because of its effect on consumption, also increases GDP and aggregate expenditure. Same with business confidence or optimism about the future, right? So these are all connected. And that's what we're looking at here. So this is the macro model. In this chapter, we're going to simplify it. So we have what's called the simplest or the simplified aggregate expenditure function, where we eliminate government. So we assume there is no government, there is no taxes, and there's no imports or exports. It's a closed economy with no government. So we basically reduce the aggregate expenditure to just the two things that we're talking about here, consumption and investments. We do this because it helps you get a handle on the concept of what we're going to talk about next, which is the equilibrium. And then we could bring back the government and just add it in. So we have the concept of a macroeconomic equilibrium, or which we'll talk about a little bit more in one of the other chapters. But here we just have the concept of, an equilibrium national income. Like with consumption, you've got this 45-degree line starting at the origin. That's national income. National income can be interpreted as what we talked about in the previous chapter, basically GDP. It could be looked at all of the income earned within a country, but basically think of this as GDP. And then you have aggregate expenditure, which we talked about in this chapter. Remember what I said at the beginning. GDP, production. Think of that as production. Aggregate expenditure, think of that as purchases. And when they're equal, it means that all of the goods and services produced within a country, so all of the GDP, is actually purchased by people within the country. We have an equilibrium. Now, what happens when we're not at equilibrium? When production is higher than our spending. Okay, so think of this as purchases or spending. If production is higher than our spending, what does that mean? Or if we're spending more than we're producing, what does that mean? So let's talk about those things. Now, before we get into that exact thing, I want to talk to you guys about something called the output gaps, which again will be with us for every chapter, or almost every chapter in this course. But in order to talk about that, you need a reminder of something we spoke about, I think, 2 chapters back, which is the concept of a potential GDP. Okay. Potential GDP is the GDP that a country would achieve, or the total output that a country would produce at full employment of its factors of production. If its factors of production are not overused and they're not underused, they're being used at their capacity. The GDP that we would get from that is called our potential GDP. But an economy doesn't always operate that way. When the economy is doing really well, we tend to overuse our factors. We ask people to work overtime. We hire more people than we normally need. We use our machines beyond their capacity. We buy more machines. The economy is pumping. So we tend to go beyond capacity. And when the economy is slowing down, we tend to go below capacity. We don't have as many shifts for our workers. We start to let people go. We don't really have demand for our machinery to be working constantly. And that's what I want to talk to you guys about here. So I'm going to zoom in on the left here. Y star, anytime you see that, that is your potential output or your potential GDP. And Y, by itself, actual. So look at this case here. The actual GDP is greater than the potential. This is an example of us working beyond our capacity. We should be here, but we're here. Workers are working overtime. Tons of people are being hired. Like I said before, lots of demand on our machinery. We're reusing our machines all day, all night. We call this an inflationary gap. The gap being the difference between them, that's the gap. Inflationary, when the actual output is exceeding the potential. It's called inflationary because it leads to inflation. We'll talk about that. On the right, you have the opposite, where the actual is less than the potential. We are working below capacity. This gap between them is called a recessionary gap. It typically means we are either in a recession or headed to a recession or coming out of a recession, but it basically is related to the economy slowing down or having slowed down. Very important to remember that, as I said, almost every chapter ties back to these gaps, to these output gaps. We'll learn like what causes the output gaps, how do we deal with the output gaps, what does the government do when there are output gaps. But for now, understanding just what they are is what we're looking at. Let's do a few practice questions on that. So consider the following information describing a closed economy with no government and where aggregate output is demand determined. So I have a note on that, by the way. You'll often see that demand determined output. So for now, we are not at all including supply. Later on, in one of the later chapters, we'll bring in aggregate supply. But for now, we're assuming that everything in the economy is determined by demand. And essentially all that means is what I wrote here. Firms are able and willing to produce any amount of output that is demanded. There is no situation where demand cannot be met. That's what we mean by demand determined output. Output is determined by whatever is being demanded. For the most part, though, I mean, there's nothing real. When you see that, there's nothing really to do with it. So we've got the what we're talking about here. We're using the simplest macro model. The marginal propensity to save is 0.25. So when I see that, I immediately like to say, well, if that's 0.25, my MPC was 0.75. My marginal propensity to consume. The autonomous part of consumption is 30, so that's your C0. Investment is autonomous at 40, that's your investment. The equilibrium level of national income. So how do you find equilibrium? Well, remember that equilibrium is when your aggregate expenditure equals your GDP. So that's what we're going to do. You set Y equal to AE. That is equilibrium. And here we're going to expand it. Remember, AE and Y, I guess in this case, is really just these two things. Consumption plus investment. So that's what I'll do. Y equals consumption plus investment. And then if we keep expanding that, think about what we talked about at the beginning of this chapter. Consumption is autonomous consumption plus induced consumption, which is your marginal propensity to consume, multiplied by your disposable income. So I'll put YD here. And actually, that's going to give me a chance to talk about this. Disposable income and national income, so Y and YD are not exactly the same thing. Y is before tax, whereas YD is after tax. So technically, YD is national income times 1 minus the tax rate. It's your income after removing the taxes. Why it doesn't matter in this question is because there's no government. So when there's no government and there are no taxes, then you can say that Y and YD are the same, but only when there are no taxes. In the chapter where we reintroduce the government, I'm going to explain to you how this starts to really matter and where you need to worry. For now, when you're using the simplest macro model, Y, YD, it's all the same. So we're just going to put y here. And then I is just I. And then you start to solve. And what we're trying to solve for is y here. So I'm going to leave y as it is. In autonomous consumption, we have as $30. They said it was right here. The MPC I found as 0.75. Y is what I'm looking for. And then investment, 40. And now we just do the math. So if we put these together, y, I'll send this over, minus 0.75y equals 70. So 0.25y equals 70. 70 divided by 0.25 is 280. The answer is E. Your equilibrium national income, the national income required for your GDP or national income to equal your aggregate expenditure is 280. Number two, at the equilibrium level, so at 280, desired savings would be what? So desired savings, remember your savings function is minus C0 plus your MPS times Y. So here we can talk about this. Why minus C0? Well, remember that your autonomous consumption is going to happen regardless. So even if your income were zero, you'd have to spend money. So that money would come directly out of your savings. So your savings automatically start off at negative whatever your autonomous consumption is. Try and imagine you had zero income. Okay, you have no income. Your autonomous consumption has to come from somewhere. It would come from your savings. So we're going to start off by putting minus 30. That is the autonomous consumption right there. The marginal propensity to save was 0.25. That was given to you. And your national income is 280. Your equilibrium, because they said at the equilibrium. So the answer here was 40. You would save $40. At the equilibrium level of national income, so at that 280, what is desired consumption? Okay, same thing. Your consumption function is what? It's your autonomous consumption, the money you're going to spend regardless, plus your induced consumption, which is your MPC, that's your marginal propensity to consume, times your income. So 30 plus 0.75 times 280 is 240. And remember what I said earlier. All of your income is assumed to go to two places. You're either saving it or you're spending it. So if you look at these two things, it makes sense that that adds up to 280 because that was the total of the national income. That should always be the case, where if you were to add your consumption with your savings, you would get the total income. Number 4. Consider a simple macro model with a constant price level and demand-determined output when national income falls short of desired aggregate expenditure. Okay, let's look at that. So you've got your national income here, your aggregate expenditure, something like this. So when your national income falls short, so when your national income is less, so let's say right here, where our national income is actually less than our aggregate expenditure, you're going to have unplanned inventory what? So this is where inventory accumulation and depletion or decumulation comes in. Think about this. Remember that this was spending. If we are spending more than what is being produced, inventories will deplete. Don't overthink it, but think about it. As an economy, we're spending more money than what's being produced. How? We're consuming not only what is being produced now, but also what was accumulated from the past. So here your inventories will start to deplete. They'll start to go down. And what companies will do as a response to that is they're going to start producing more, which is the logical response, guys. What would you do in your business? If you see that your inventory is depleting because you're producing 10 units a day, but your customers are buying 20, how are you going to respond? You're going to start making 20 units a day to try and meet your demand, right? So unplanned inventory depletion, which will induce firms to increase production. So B, raise the rate of output production. That's what happens when you're not at equilibrium. And by the way, the opposite is true as well, okay? If all of a sudden we're producing more than what's being purchased, what are we going to do? We're going to slow down. Now, what happens? We're going beyond this question, but it's important. This leads to an economy that starts to expand. As we start to increase our production, your economy starts to expand. Remember the business cycle? We start to go up. Oh, we're not producing enough, produce more, produce more. The economy grows, grows, grows. That's nice. This over here, this typically is a sign that we're about to slow down. It's like, oh, we're producing too many goods. Let's slow it down. And then the economy starts to slow down and then come down. So this leads to expansion, right? When your production is below your spending, it leads to expansion. But when you're producing more than what people are spending, this leads to contractions or recessions. Make sure you go back, if you're not remembering, make sure you go back to when I talked about the business cycle in one of the earlier chapters. Okay, now changes in the aggregate expenditure function. This is when something in the equation changes. So again, let's keep it simple. AE, which is C plus I. And then if I expand this, just expand these two components, C, which is your autonomous, plus your marginal propensity to consume times your national income, plus your investment. These two here are autonomous. This part is induced. Remember, autonomous will happen regardless of income. Induced is a function of income. Well, if any one of these changes, you're going to have a change in the line. So if you have a change in anything autonomous, like your autonomous consumption or your autonomous investment, that is going to shift your line up and down. From a linear standpoint, you are changing your intercept. The intercept of the aggregate expenditure is anything autonomous. The intercept in this case would be these two. And so if you change the intercept, you're going to shift your line up or down. Up if you increase it, down if you decrease it. Now, if you change the MPC is the slope. That would rotate your line. It would do something like this. The autonomous assume would stay the same, but you would have a rotation either up or down. So if you have an increase in the slope, so if the MPC increases, and by the way, all this is written here, you don't have to write it, but you see if you have an increase in the MPC, you're going to have an upward rotation. I've summarized here all the different things. Anything autonomous you see would be a shift. So this would be shifts up. And when it goes up, the GDP goes up. It's easy. Up, GDP goes up. MPC, which is a rotation, because it's a slope, MPC goes up, rotates up, GDP goes up. MPS, which is the opposite of the MPC, you want to be careful, right? The more we're saving of every dollar, the less we're spending. So you have a downward rotation, which would decrease the GDP. And then finally, marginal propensity to spend, which we didn't really talk about yet, but we'll talk about it right now. This is also the same thing. It's the slope. Now this, remember the aggregate expenditure function. Again, I'm going to expand it. I'm going to write it out like this. And then I'm going to expand it. Autonomous plus MPC, so plus your induced, plus investment. And then I'm going to rearrange it, where I'll put the autonomous together. So really it's this. The autonomous expenditures, so those two, plus your induced, which is the MPC times Y. And why I'm writing it this way is because I want you to see it as a linear equation. Y equals, this is your intercept. We'll call this B. This is your slope. We'll call this M. And this is your independent variable, which is normally X, right? So I'm writing it this way because you might recognize it. Y equals MX plus B, right? So the slope of the aggregate expenditure function has a name, and it is called the marginal propensity to spend. We use this symbol Z. But again, for the simplest macro model, the marginal propensity to spend is equal to the MPC, because we don't have any tax, we don't have any imports, we don't have the other things that are going to be affecting it. So for now, those two are the same. Which brings me to, I believe, the last part of this chapter, which is something called the simple multiplier. Then we'll do some practice. Like it says in the notes, it measures by how much the GDP will change as a result of a change in the autonomous expenditure. So for example, if as an economy, we start to spend more on investments, which is an autonomous, it's part of the autonomous part of our aggregate expenditure. So if that goes up, how will that affect the GDP, right? If we looked at it on a graph, again, I'll always come back to the graphs. Graphs are super important in this class, like in any economics class. You've got your national income. Then you've got your aggregate expenditure right here. And remember that the autonomous is that part right there, the intercept. Now, if I were to shift this upwards because of an increase in, say, my investments expenditure, the equilibrium real GDP would move from point A to point B. That's what we're looking at here. How much will this change? How much will that upward shift? How much will it change the equilibrium real GDP? That's what the simple multiplier measures. And the formula is pretty straightforward. 1 divided by 1 minus the marginal propensity to spend. The slope, in other words, of the AE function. One thing you can make a note of here, the higher your marginal propensity to spend, the higher your simple multiplier. The more your GDP will change as a result of a change in autonomous expenditure. So let's do a few examples on that. Question number 1, consider a simple macro model with a constant price level and demand determine output. You see there's that sentence again. Doesn't really tell you anything. Just know that we're in this chapter. In such a model, a downward shift in the savings function, okay, freeze. A downward shift in the savings function. So what would cause a downward shift in this function? When we're talking about shifts, you're always thinking about the autonomous portion, the fixed portion. So if this were to shift downwards, this would become smaller. So essentially, you are consuming more autonomously. Your autonomous consumption is increasing and therefore decreasing the intercept of the savings function. So what would happen there? Okay, so if you have a downward shift in your savings, you would have an upward shift in your consumption. Connect those dots for a second. Remember what we talked about already. If you're saving less, it's because you're consuming more. And if you're consuming more, your aggregate expenditure is increasing. Because again, what is aggregate expenditure? Consumption plus investments. And because we said it was the autonomous part, because it's a shift, you're going to have a shift in your aggregate expenditure function, and it's going to be a shift upwards. So this will cause the equilibrium national income to rise because the AE function will shift upwards simultaneously. And don't just scroll away from this question. Think about it. We said it was a downward shift. So we know that that's caused by something autonomous. A downward shift in savings is an upward shift in consumption. So you have an increase in your autonomous consumption, which will shift up the aggregate expenditure and therefore increase the real GDP. Number 2, consider the simple macro model with demand determine output. Suppose an increase in business confidence leads to firms increasing investments. Okay, increasing investments in new equipment by 100 million. The marginal propensity to spend in this economy is 0.75. What is the increase in expenditure in the economy during the second round of spending? Okay, so this will allow me to explain to you guys really how this works. When we spend $100 million more on investments, think of that as the first round of spending. Firms are going out there and spending 100 million. They're putting it into the economy. And we've talked about the circular flow of the economy and how as you start to inject money into the economy, it starts to circulate. Well, the economy is spending 75% of every dollar. So in the second round of spending, 75% of that 100 million will be spent. So the answer is D. And it's the same thing. That 75 is re-injected into the economy. And in the third round, 0.75 times 75 million $56.25 million is re-injected. So from that first $100 million that was spent, look at all of this economic activity. Just in 3 rounds, we have spending of, let's do the math here. If I add the 3 together, 231 million, 231.25. Just from that first $100 million of spending, the economy had $231 million of spending just in the first 3 rounds, and this will continue infinitely. And that's what that's what the simple multiplier tries to measure. How much will it end up affecting the GDP? In 3 rounds, it affected it by 231, but by how much would it affect it overall? And I want to expand on that question. Here we have a marginal propensity to spend of 0.75. Okay, I'm not doing question 3 right now. I'm going to find the multiplier. So 1 over 1 minus the marginal propensity to spend. So 1 over 1 minus 0.75 is 1 over 0.25, which is 4. That's the multiplier. So if I took my $100 million in new autonomous expenditure and I multiplied it by 4, this tells me that it would increase the total GDP by 400 million. If you were to add up all the rounds of spending to infinity, you would have an increase of $400 million in economic activity. That's what the multiplier does. It multiplies the change in autonomous expenditure to show what is the change in total economic activity or total GDP. Okay, number 3. Consider a simple macro model with constant price levels and demand-determined output. If the marginal propensity to spend is 0.6, what is the multiplier? So we just did that, the formula being this. 1 over 1 minus 0.6 is 1 over 0.4, which is 2.5. So that's it for this chapter. Very important chapter because it really sets the foundation for what we're going to be doing in all the other chapters and understanding how a change in one thing will ultimately affect the GDP, but you have to understand how. So when I change my autonomous consumption, it affects my GDP. When I change my investment expenditure, it affects my GDP, my MPC, my MPS, all the things that we talked about. Once this is really clear, then we're free to bring in the government. And in the following chapter, we're going to bring back the government, so G, and we're going to bring back exports and imports. So we'll have a reconstructed AE function with all the different components. So we're going to have tax, we'll have imports and exports, all the things that make this a little bit more complex, but ultimately it'll come back to the same thing. Okay, if you have any questions at all, please do not be shy. I will see you at the next one.